Good morning, everybody, and welcome to this webinar from the Transforming Construction Network Plus organization. Just a few words before we commence about the Network Plus organization to familiarize those of you who are not aware of it. First and foremost, my name is Paul Ruyssevelt. I'm a co-investigator with the Transforming Construction Network Plus, and I'll be your chair for today. You can see your speakers lined up there, and I'll introduce them to you as we go through the presentations. As the slide is showing, the Network Plus is a collaboration between three universities: University of College London, Imperial College, and University of Warwick. And the aim of the Network Plus is to support the transformation of the construction industry, bringing together digital systems, supply chains, manufacturing into new ways of working that are hopefully more efficient and more effective in delivering our built environment. Our aims are to develop knowledge, to build the communities within the UK and internationally, to try to develop new business models that make these more effective methods of construction viable, and to develop an investment and leave a legacy for the industry. Next slide, please. So our webinar today is looking at the international experience around off-site construction and energy efficiency. And we have three speakers. Dr Thaleia Konstantinou from the TU Delft in the Netherlands, Professor Deo Prasad from the University of New South Wales, and Dr Malay Dave, who is also from the University of New South Wales in Australia. So without further ado, what I'd like to do now is introduce you to our first speaker. So Dr Thaleia Konstantinou is an assistant professor and chair of building product innovation at the Department of Architectural Engineering, the Faculty of Architecture at Delft University. And she studied architecture and qualified as an architect at the University of Athens, and she undertook her PhD at TU Delft. Her research topic is the facade refurbishment and strategies, and she's currently looking at energy efficiency, the circular economy, and facade design and construction and industrialization. So at this point, I'd like to hand over to Thaleia to take us through her presentation. Thaleia, you have 20 minutes, and I'll give you a 3-minute warning.
Yes. Thank you very much, Paul, for the introduction, and of course for the invitation. I'm very glad to be here and to have the chance to share our experiences. So I'm going to talk about some projects we have been working on in my university, in my department. As Paul explained, I work in the Faculty of Architecture. My department is more the technological part of architecture, so we do focus in the actual construction and other implications that this has. And then the focus is in general, how can we in the end get zero energy retrofits, and how we need integrated approaches to achieve that. Yes, so to put this a little bit into context, of course, we start by the need to reduce the energy use, and particularly reduce the energy use in the building sector. So we all know how we need to have zero energy buildings. All new buildings need to be zero energy already this year, and how we have in Europe, in the Netherlands, also in the UK, ambitions for zero carbon built environment. And with this context, there's a clear ambition to look at the building stock, at the existing building stock. And the reason for that is because we cannot really decarbonize the whole building stock if we do not look at the existing buildings, given that only 1% is added to the stock every year. This means that by 2050, when we want this to be basically don't consuming any energy, only 30% of the stock can have the standard that we set now, while 70% is already there, and it has far lower energy standards. And that's what those graphs are showing. That's a graph I really like. That shows that basically 80% of the buildings have an outdated glazing. So only like less than 20% of the buildings have high performance double or triple glazing. And that's another graph showing the energy label distribution in the Netherlands. But I wouldn't be surprised if the situation is similar in other European countries. That shows how the majority, for example, of buildings built in the post-war period, that's the blue bars, they have a label of D or lower. And speaking of the stock, just to understand a little bit the age of the stock, because that's a decisive factor of the condition that it has. In the Netherlands, 1/3 of the stock is built in the post-war period. That's why it's an important period to look at. And in the UK, this graph includes both countries, which I found interesting. The situation, I see the actual numbers are a little bit less, but still is a very big percentage of the stock that is in this period. And the post-war building stock has been on the focus in this refurbishment discussion, but we should also think that also the next period, the period between 70s and 90s, that's also a period that needs attention, because those buildings are already 30 years old or more and are reaching the end. A lot of their components reach the end of the life span. So we see that we have a lot of buildings to work with. So the refurbishment does have the potential to increase energy efficiency and to decrease the energy use and help reach all the climate goals that we have. However, at the current rate, this will not be possible. So both rate and depth need to increase. And that's a graph, and that's already from a few years ago, that indicates that, and if we say like we start with a renovation rate of about 1% of the stock being renovated every year, that's what it says, that we need to get to 3 with a kind of projection by 2020, when we have almost double the rate of renovation, but unfortunately this is not the case. So we're still not far above the 1%. Maybe we are currently at 1.5 or something. And what is also important is the depth of renovation, which means how much more efficient the buildings need to become. So it's not enough to only replace the windows, for example, but we need to have solutions that really achieve savings of more than 60%, and ideally zero energy buildings. And I'm going to show you in a while how this is indeed possible. So the numbers need to increase. In the Netherlands, it has been estimated that we need to renovate 300,000 dwellings every year in order to get those goals. So given the high amount of number of renovation that we need, prefabrication and offsite construction comes into the picture. And industrialized construction is often used interchangeably with prefabricated construction. However, it's good to have in mind that this is not exactly the same, because prefabrication is one subset, let's say, of industrialized construction. We have other degrees of industrialization, like automation and robotics. But in any case, what is important to consider is that for industrialization to make sense, we need the high number of buildings. That's why now it's relevant, but at the same time, it's also a challenge to achieve that. And industrialization is not a new concept. That's some images of this post-war period, where industrialization was conceived as a way to produce a large amount of buildings that we needed for the reconstruction of the countries. So these are all the systems in the Netherlands that were used, and either with prefabricated large components, like in this picture, that's the system called VAM, or with smaller concrete blocks, that's the system called MOVI. But they all had the underlying objective of increasing the number of production. And as maybe we all know, this did not go exactly ideal as people has envisioned. So the question is not about repeating it, but how can we actually use what we learned and increase and apply the things that are useful for us now. And maybe one thing that helps having industrialization and industrialized building, like in this case in the stock, is that there are a lot of characteristics that are the same, and this helps also for the replicability of the solutions. So now when we talk about industrialized retrofit, of course, as I said, it's not about repeating what was happening before, which was anyway for new construction, but we need to use the potential that industrialization offers to increase the effectiveness, the productivity, but also the quality, and at the same time minimize on-site construction time, which is also important given that in refurbishment, in many cases, the people are already in the houses as opposed to new construction. And we need to minimize the disturbance to make the whole process better, but also in the end feasible, because people need to accept it. And what is more important, and what is it's maybe new compared to past industrialized approaches, is that now with industrialization we have the chance to integrate more technologies, such as building services, but also reach very high standards of performance with the integration of big amount of insulation or other material that can achieve that. So I would briefly like to mention Energiesprong, which you maybe have heard already, because that's an initiative that started in the Netherlands. It's not something I have personally worked on, but it's developed at the same time as other similar projects that we were doing, and we were in contact with the people working on it. So Energiesprong is more a kind of an approach, a concept for a whole house refurbishment, and it's the approach about the construction, the prefabricated construction, but also the funding that can make this renovation possible. And it's based on long-term performance guarantee for the climate and the energy performance. And the business model is that the amount that people would normally pay to energy bill and maintenance go to pay off the retrofit. And at this point, it's worth mentioning that Energiesprong has the objective of zero energy performance, or how we call it in the Netherlands, NOM. It's nul op de meter, this stands for. And it's not only zero energy for heating, for example, but it includes both building and user-related energy consumption. So also the appliances and hot water and so on. So in the end, you have zero on the meter, you have zero energy bill. And it has been quite a successful project, and it has been internationally exported, let's say, also in the UK through the Transition Zero project, but also in other countries like France and Germany. And this is one of the first cases. I think it was constructed around 2014 in a small city in the Netherlands, where they renovated the row houses, 55 terrace dwelling, to go zero on the meter. So that's the NOM standard, as we say it here. And both facade elements and the roof were prefabricated and arrived in one piece, as we see here, with already windows and doors integrated. Those panels are made with a timber frame construction. Also there is an installation building services unit. It's like a box that is put in the backyard, and it includes all the building services, which would be heat pumps and heat recovery ventilation. And this renovation, it took about 10 days per dwelling, including everything, so including and reinforcing the foundation so that the panel can go there. And then it was kind of 1 day for the front facade, 1 day for the back, 1 day for the roof, and so on. So it was really, really fast and effective. And since this is around for a few years already, it has been monitored. And basically the results show that the performance matched what was predicted during the design phase. And the space heating is a little bit more than expected, but and also the energy generation through solar is a little bit higher. So overall, it performs as expected, and that's very important for the energy guarantee, which is a concept that makes the whole thing feasible. And that's also something that we did in our project. That's that's a project I have been working. It's called Second Skin, not because it had a double facade, but because we envision putting a second skin in the existing building. And similarly to Energy Sprong, we wanted to have an integrated approach, not integrated not only in the sense that all the components are integrated, but more in the sense that all the aspects of renovation are addressed. So we have the technical aspects, that is about the technology and how to reach zero energy without intervention in the interior, but we also looked at the business development and how can we upscale it, bring down the cost down, and user aspects, including acceptance and monitoring. And it had different stages, starting with the mock-up. Then we have 12 zero energy buildings, and the last phase, which was the more recent, it had 120 zero energy ready. So they were not zero energy, but they could be upgraded in the future. I'll go, and this approach of steps fitted a little bit our idea that we need to develop towards a product, and in order to innovate, especially considering industrialization, we can start with existing technology and then see how it performs. And when we have confirmed performance, then it will be easier to make more integrated building products. I'll go a bit fast about the first phase. So our concept is quite straightforward. So we remove existing windows, the walls stay, and then we have this ventilation layer, how we call it, which is this part when the ventilation pipes for the heat recovery are running, so they are connected with the unit in the roof. And then the facade panel, it consists of sandwich panels, and they are attached to the existing construction through these wooden beams, and then the PV panels are on the roof, are not visible in the facade. Although there is the possibility, if needed, to add them to the facade, since there is a separate cladding on top of the sandwich panel. And we make a mock-up to test the technical feasibility. So these are some pictures of how this looked and the connections and how easy it is to assemble it and how many people are needed. And that's the inlet for the ventilation pipe to the space. And we tried also some different types of cladding. And with those findings, we went to the next step, which was actually applying it in a real project. That's a block in Vlaardingen, that's a city in the south of the Netherlands. And this building is a very typical post-war district. This is the building in question, but all those buildings are exactly identical, and actually those are the ones that are renovated in the next phase, in the zero energy ready phase of the project. And those buildings are constructed with the industrialized construction system called Simplex. These are some historical pictures and drawings. So we have these prefabricated concrete panels that make up the walls and floors, and brick cladding to give a more kind of desirable image. So that's how it looks. Those are, maybe to mention, these are rental apartments owned, and the whole district is owned by a housing association. So that's the proposed design from the architect for this building. So in the facade, that's a standard system of external insulation. It's not the sandwich panel we had proposed, because it just was not financially feasible for such a short, small scale building. So that's something really to consider. So that's a little bit to our disappointment for the process, but that it had to be built, and we still incorporated a lot of the things that we learned from the first phase there. But to some extent, the first phase was the more generic in design, and now it had to be more adapted to the specific project and the specific conditions of the project. The windows are replaced with triple glazing. And the roof are indeed prefabricated panels that so the current tiles were removed, the structure stayed, and then the wooden beams, the existing wooden beams stayed, and the prefabricated roof panels were attached there. One thing that was interesting about this project was the balconies, that it was decided to cut and replace them. So this is so that the insulation could run through, but also have a new and bigger balcony. So that's the phase where the first one was cut. A few minutes later, that one was cut. That was one of the biggest intervention, and also one of the biggest expense in this project, because this new balcony is requiring new foundations. But it was also, apart from giving the added value to the building, it also gave the possibility in this part to construct a prefabricated box that included the building services. So here we see the heat pump and the water buffer. Also, it's not there yet, but there's also ventilation unit with heat recovery. And the ground source heat pump, so the heat pump is a ground source heat pump with a very high COP of 6. And this is from when the hole was dug. It went down all the way to 190 meters. So that was in the backyard. That was again one of the main, one of the big expenses of this project. And that's also something, 3 minutes, okay, I'm almost there. That's also something that it's a little bit specific to this project, because not all projects will have this backyard and will have the possibility to have a ground source heat pump. But it was a very efficient solution. So in combination with this, with the photovoltaic panel that were installed on top of the roof panels, we were able to give a zero energy guarantee for 25 years. So that was one big factor that made this project feasible. So how it worked is like, this is a slide that was communicated to the people. So the people continue to pay the rent, of course, but instead of paying the energy to the energy company, they pay an increase in the rent that was actually, it's regulated through the government through what is called energy performance subsidy, which is a fixed amount. So, and then maybe if there is extra energy needed, they pay at the end. So with this subsidy goes to the housing association, and with this it can cover the investment that the housing association as the owner made. And then the occupants are given specific budgets for energy, that was defined by the performance guarantee and the contract, the agreements between the parties. So what's interesting is maybe the business model, which in that case, so we have the general contractor who made a construction and maintenance guarantee with the housing association, the owner, but also organized the whole process of construction. But there's also a separate party that provided the energy performance guarantee. So the owner had to deal with two different parties. And one suggestion that we want to make is that to change this supply chain organization, even though more or less the similar parties are involved, so to form one, in a way, like a one-stop shop that the owner has to deal with all the performances, instead of having to arrange this with the two different parties. So that's one improvement that we want to make, and we are on our way there. So the general contractor, Big Bow, is leading the process, and the new company. Just to highlight the role of the users, because that was an important part in our project. So the user, first of all, they had to accept it. I'm very close, and they were together in the whole process. And with this, we managed to have a very good acceptance of 100%. They were there during construction, and there were absolutely no complaints, because of course it was an inconvenience for them, but they were informed and the timelines were kept. So we see this gentleman here watching TV while his window is being replaced. And now it's being monitored. I don't have all the results yet, but I can already say that the energy production is more than it was initially calculated. And that's proposal, that's the renovated result. So to conclude, zero energy retrofitting is possible with current technologies, and there is a potential to develop this towards a product we have to think about the business model with energy contracting, because that's very important, and you saw it in our project also in Energiesprong. Main restriction is still the high investment. That and maybe as an outlook, I think we need to see how with this increased number of renovation that we have to do, how industrialization can come more into play, because still it's not the current practice. It's more a kind of in a pilot ways. So if we increase that, there are potential to also bring the prices down, and also make the whole process faster and increase the numbers. And we can also need to look at alternative solutions like the stepped renovation, or how to combine it with low temperature energy system and so on. One message to live with, like refurbishment is something that is going to happen because it's part of building's life cycle. What we are looking at here is how we can make this more efficiently and effectively to really go to zero energy solutions and address our climate goals. Thank you.
Thank you, Thaleia. I switched microphone. Can you hear me okay?
Yes.
Yeah, okay, that's good. Yes, thank you. We will hold questions until all speakers have spoken. So we'll just move the slides through now, and I'll introduce our next speaker. So our next speaker is Professor Deo Prasad from the University of New South Wales in Australia. And Deo is going to introduce the state of play in this field in Australia to us. Deo, until recently, has been the CEO for the Low Carbon Living CRC project for 7 years. He's a very eminent researcher and academic in the field with many publications to his name, and tremendous experience across the energy efficiency and built environment sector. Deo, over to you.
Thank you, Paul. I have a tag team presentation with my colleague, Dr. Thaleia, and we will. I'll talk more broadly about the slightly macro scene in Australia, and Malay will talk about the more specifics of modularization and construction. So I'm trying to get my slide change. Okay. Okay, it changed. I'm not sure if I managed to do it or remotely. Anyway, so things I will cover would include some mandatory measures in Australia in terms of energy in building at time of design and so forth. Energy issues are more state-based. If you know, in Australia we have the federal government system, state and local government. So most of them are state government issues. I'll also mention some voluntary measures driving change. A new, relatively new initiative that is driven by climate emergency, which is gone global, but I will talk about what we are doing, which is also driving change in this area. And a lot of that is leading towards more efficient ways of construction. I'll give a few examples where timber structure in construction has come about and been trialed and tested to work well, and also then put a lead in towards prefabrication and modularization, which my colleague Malay will take on. So to start with, let me talk about my university here, New South Wales. When you look at driving towards zero carbon and low energy buildings, and in our case, a precinct at a time, the entire campus, we at the university decided to go down that path of zero carbon very quickly. So obviously you try the level to which you can get cost-effective demand side efficiency, then explore how much renewables you can get on site, and what role storage can play, and then look at offsite. And we went through the process and ended up with a very large offsite generation facility, which the university invested in, and working with a utility which has all the poles and wire access, if you like. The site is very far from the university, about 1,000 kilometers away, but we then get it to the campus well, offset our energy through green renewables generation. So if you look at the graph here, the total generation offsets the total demand during operational phase, and that's our way of quickly getting onto zero carbon. There are better ways, both through refurbishment, and Thaleia has mentioned a number of approaches that she and in Netherlands they have been following, but this is just a quick way of driving precinct scale change. Within driving change sort of area, the building code of Australia is a key mandatory approach, and we have had a poor record in terms of having building code that drives low carbon buildings. In more recent times, we have had residential house energy rating systems, and in commercial, we have been looking at more the system side of things, but they have been successful to certain degrees only. What my center recently did, which is the report here on the left, looked at a trajectory approach where we look at the business case and the technical case for going down a pathway 10 years at a time, so that you can actually know what the next 2 or 3 changes might be that drive us towards zero carbon. It gives you the confidence, obviously, of knowing as a manufacturer what products might be needed, so you can innovate for products and systems and technologies, but at the same time progressively meet compliance towards that trajectory and pathway. So this is now approved by the Coalition of Australian Governments, and we are soon going to have a trajectory approach embedded into the code, which is a really good way of moving forward. That will drive all types of construction. We within our research center have also looked at actual demonstrations to look at building a house at a time with real-time families, and look at how you can achieve zero carbon without that much of a cost penalty. This is a house called Josh's House. It's available in terms of live performance on the web. If you just put down Josh's House, and this shows a family of 4 can easily do that in a normal-looking suburban house in Fremantle. And we collected a lot of evidence through a number of other living laboratories where we demonstrated zero carbon is achievable cost effectively within different climates in Australia. As you know, Australia spans a very tropical north to very temperate and cold south at the moment. And collecting a lot of data, we fed into the government, and in this case, the Victorian government has started with a policy enabling zero carbon, working with larger developers to give them subsidies to drive change towards zero carbon. So having collected the evidence, we're trying to apply it to drive policy, in other words. We also, in New South Wales, looked at other ways. In this case, they were interested in the role of behavior. You can design a 10-star building, but if the people are operating at 2-star, you will only get a 3-4-star performance. So we looked at the role of behavior, and a number of projects we did were directed towards better understanding how people behave and how you can intervene within that. In this particular project, we were trying to get people to actually consider renovation at the time of that decision to rebuild. We had, there's a very famous program here, television program called The Block, and that is a refurbishment-led program on Frontline TV. And we developed a series around more sustainability-led parameters, where we were trying to see if we can convince a real-time homeowner as to what decision to go for. So in this case, this is being picked up by a television network, and we are going to take people through the journey of deciding on which way to go, refurbish or rebuild.
While 3 minutes to hand over to.
Thank you. We looked at how one could actually do peer-to-peer trading at a community scale, precinct scale. And Gemma Green developed this Power Ledger platform, which allows for peer-to-peer trading, and it won an award from Richard Branson at the Davos World Economic Forum a couple of years ago. So that allows you to do a number of things. We, under climate emergency imperatives, have started looking at guidelines very much targeting zero carbon. So this will apply to all types of buildings, but developing a clear idea based on, well, not based on necessarily, but looking at what RIBA has done. We developed a number of parameters around and metrics that we want to look at. And even the London Energy Transformation Initiative has developed a guideline which we looked at, and we are at the moment trying to develop our own guidelines from all the evidence we have collected, but at the same time looking at what others have done to drive towards zero carbon pathways. A number of buildings have evolved that have taken these high levels of stringency in codes, as well as tighter envelopes and things. And there are buildings. This is a 9-story building a few years ago, 5-star ranked, and we have International House. These are all timber framed, and that enables it to be a lot more driven by modularized construction. So going more and more towards timber frame and modularized construction, managing waste at the same time. And a number of these have moved on to the point where the designs of large, well-designed buildings are getting quite sophisticated. In this case, at our university again, a very much timber-driven, low waste, low energy type design, which has been put on hold under the COVID sort of season, if you like, at the moment, but we hope it will get going, and it will be a demonstration of how a largish building can actually take on a lot of these capabilities. What we have done is produce a lot of guidelines for renovating as well as new designs, and these are widely available in Australia. And even earlier today in a government workshop, we had made these available for them to take these on board and take it to industry more widely, so that we can engage industry and others in enabling low carbon and more efficient construction. So I will pass it on to my colleague, Dr. Dave, and Paul may wish to introduce him.
Thank you very much, Deo. Yes, I'll press on and introduce Dr. Dave, and then we will have questions after that. So Dr. Malay Dave is a sessional academic at University of New South Wales. He has his architecture degree from Forte University in India, an institution I know quite well, and I'm sure he had some very good instruction there. His master's degree in built environment was at the University of New South Wales. Until recently, he worked as a researcher in the multidisciplinary team, Cooperative Research Centre for Low Carbon Living, and he was awarded his doctorate there. And he's been involved in assisting the Australian prefab housing companies addressing their design, sustainability and affordability issues. And I'll pass over now to Dave if you're there. You want to switch on your video, Dave?
Thank you, Paul.
Malay, sorry.
Thank you for the introduction.
Thank you.
Okay, I will press on. I today want to just talk about 4 key areas. First is I want to talk about the promise and the reality of prefab, briefly touching upon what are the key advantages and whether we have achieved those advantages or not. I want to talk also about the collaborative research that we worked on at CRC for Low Carbon Living here in Australia. Just talking about a collaborative research we did with an industry partner. Then I will quickly touch upon the recent challenges we have experienced in Australia in the prefab sphere, and what are the future directions. And then we'll share a few key insights on them. So this is quite well known. Prefab is, again, whether we use the term offsite construction. I will, for consistency, use the term prefab throughout my presentation. Prefab is well known to provide some key advantages in construction. That includes increasing the performance on sustainability, increasing the quality, greater control on the timeline, and reducing costs and waste, etc. So this is the promise that we all know quite well. However, the reality of prefab is slightly different to that. And throughout the research that I have conducted as part of my PhD, it's internationally quite well known now that it's not necessarily the case. It is still struggling with some barriers. I want to highlight two of the key documents that came out, one from UK and one from Australia. Both were Vision 2020 documents on construction and how to advance construction to achieve high performance and to achieve the goals that we want to see both environmentally, from productivity point of view, and cost. Both talked about prefab or offsite construction as one of the key pathways to achieve this performance in construction. Interestingly, the 2004 report from Australia that you can see on the right side of the slide also considered did actually a very extensive survey of industry stakeholders and experts, and it found that all of them considered prefab to be an imminent disruption in the industry. They thought that within 15 years, prefab will be mainstream. Now we are in 2020, middle of the year, and it's unfortunate that that is not the case in Australia particularly, and it's not too dissimilar from other countries internationally too, that prefab still remains in its infancy. In Australia, it is considered that only 3 to 5% of the buildings overall are using the mechanisms of prefab and offsite construction. So that's a major setback that it has experienced compared to what was hoped and expected. However, the governments, both at federal level and state level in Australia, are giving signals that they want to see this change quite rapidly, and they want to see within next 5 years it to rise to 15% of the total construction being prefab. So considering the current reality, I want to talk about some key barriers that I have found through my research. There are many that are quite universal in nature. Actually, the initial cost is still considered to be higher than the traditional or conventionally constructed on-site building. Although the cost is actually one of the key advantages that may be achieved, we have not yet developed outstanding evidence that this is happening in all buildings. Actually, majority of the construction is finding it as a barrier to achieve high performance. Another associated aspect of cost is the value. The difference between cost, there is a perception in the society that the initial cost reduction is the paramount aspect, and that then compromises on the value, and that creates a major issue with prefab deployment and acceptance. Associated with that is another barrier, which is related to economies of scale. Prefab achieves reduction in cost primarily through achieving economies of scale. If we cannot have large amount of market, so large size of market and high degree of repetition and standardization, that economies of scale cannot be achieved, and hence the cost remains a barrier. To achieve this high economies of scale, again, we need a high take-up of prefab, which is not happening because of the negative perception within the society. This is, again, a universal phenomena, but definitely in Australia, we have what we call demountables, old modularized metal constructed school buildings that are quite well known for being very low quality in terms of its thermal performance, also aesthetics. So that has created a lot of negative perception, and that is also having an impact on acceptance of prefab. There are other barriers, which includes industry knowledge, awareness, interest in implementing some of the innovation, and low implementation of R&D within their businesses, and so on and so forth. So I want to talk about one project that we worked on here that tried to address some of these barriers. This was the project we worked on. A company called Novadeco, a modular housing company based in Australia, however, having fabrication facilities in China, approached us. They wanted to develop very high performance modular housing that was highly environmentally sustainable, but also economically affordable for primarily Australian market to start with, but also potentially internationally applicable. We looked at design as a central aspect to address a lot of issues. We conducted thermal performance simulation-based parametric modeling. We did LCA studies, also on-site monitoring of their existing designs, and quality assurance studies within their factory in China. What I want to particularly touch upon today is the aspect that modular housing or prefab of this nature struggles with a particular challenge that is quite different from conventional buildings. Conventional buildings are designed for one site or project at a time, while prefab has to address multiple climates. Australia has very different types of climates, from tropical hot humid to very cool climates. So we conducted sensitivity analysis and came up with final design that was able to achieve high performance on all different climate zones, achieved not only regulatory compliance, but went quite beyond the high performance mark that the company was expecting. So that is, we were able to achieve mass customized product that was able to achieve very clever changes within its design to address the climatic response requirements as well as client requirements. I'm reaching towards the end of my presentation. I want to quickly touch upon the recent challenges we have experienced in Australia due to market forces and some economic turbulences. Within last few years, many companies have closed down their shop. Either they have downsized or moved overseas or suspended their operations. These are the three that I just quickly want to touch upon amongst many. Tectum, high quality modular housing, the strong build in the middle that was a pioneer in prefab, a really good construction using CLT, cross-laminated timber. And on the right side is Archie Blocks. This particular house that you are seeing on the right side was the first carbon positive house. They termed it carbon positive. It went beyond zero in terms of carbon. So really good design, really good construction systems in all three. However, they had real struggles. What this essentially talks about is that good design and high performance construction systems are not essentially going to guarantee the success in prefab. There are many factors, including business model, market forces, social acceptance, and many other factors are quite important to consider. Pressing ahead, there are many other companies. On the left side, Mode Homes, very innovative patented technology that I worked with, also is pressing ahead and expanding. On the right side, Hickory Group, possibly the most advanced company in Australia, developing from modularized bathroom pods to high-rise towers. On the right-hand side, you can see the highest tower, modular tower, 44-story tower in central Melbourne that they have built recently. So a lot of work is still happening, a lot of innovation is still happening, and the future is actually quite bright, particularly also, and this is my last slide, second last, there is a lot of work happening in different institutes and organizations. We've talked about CRC for low carbon living. There is an ARC Center for Advanced Manufacturing for Prefab Housing in Melbourne University. There is Zero Energy Mass Custom Homes Network. Also, there is a Prefab Oz, which is a peak body driving a lot of research in this area and community interest. Advanced Manufacturing Growth Center has recently received a lot of funding by the government to establish an innovation hub in this area. And the building 4.0 CRC based in Monash University is an upcoming research hub that will drive a lot of innovation in this area. So coming to a conclusion, there are 5 key insights I would like to share with you. First is there is a need for much greater collaboration between industry and academia in this field. Industry has been quite risk averse in Australia in taking up this, but there is a lot of opportunity there. Second is the greater emphasis on R&D that requires a lot more investment from the industry side as well as from government. We need to look at affordability, not just as initial cost, but look at the value in at a life cycle stage. Sustainability has to be considered holistically. It has to embed within the system level rather than as an add-on to buildings. And last, but most important, we need to put design at the center of all these challenges. Whole systems design, particularly looking at systems thinking and looking at prefab, not as a one-off project, however, but as a product or a process-based. So I'll end that point there. Thank you.
Okay, thank you very much, Malay. If I could ask the other speakers to turn on their video and microphone so we can enter the panel session. So thank you very much, everybody. We have some questions to address, and I will go through the questions, ask them, and either direct them to individuals or ask the panel as a whole to respond. The first question I'm going to go to is from Peter Kaig, and he asks that Japan has built 950,000 prefabricated houses in 2019, the majority of which were equipped with home energy management systems. Why does Europe, and potentially Australia as well, lag behind with these technologies? I think you were giving us some of the answers there, Malay, but Thaleia, perhaps do you want to speculate on some of the reasons we're so far behind?
Yes, so I mean, I know more about refurbishment because that's my focus on in new buildings. I think prefabrication, to not total prefabrication, but prefabricated elements are already happening a lot more. I think for the refurbishment market, one thing is that even though we have large numbers, since there are existing buildings, that everybody has some tolerances and thresholds, and so you need to apply a prefabricated module to an existing building. So this already increases the challenge. And then, of course, as I mentioned already, is about having the right number. So right now it is a little bit fragmented. So one housing association has few buildings or targets in a specific time, few buildings, so it doesn't make sense, and the factories are not there yet. One thing we are looking at that's a little bit more on a policy and administration level is to, how they call it, bundle the demand. So the housing association come together and kind of promise that throughout the timeline we have this amount of buildings to renovate. So one thing is the numbers, the second thing is the tolerances, and the third and most, well, I don't know, maybe I have 4 in the end. So one other thing is the cost, that the funds for renovation is in generally quite low and quite limited. So just to give you a frame of reference, housing association would have for the regular renovations, not like and maintenance. What the plan is around 30K per dwelling to have renovation after 30 years, while the cost of what I showed both for second skin and the energy sprung, as far as I know, is similar, is more in the area of 70K.
Okay.
So it's like double. Of course, this 30K is not for zero energy, so we need also to be able to shift. So I would leave that. There could be a lot more, but that's for the renovation because there are more challenges.
Yeah. Okay. Well, we'll come back. We've got another question on renovation there. I mean, I guess some of the things you were saying in your presentation would seem to suggest that sort of market and cultural issues have an influence here, and maybe there are some key differences with Japan there.
Yes, that's quite right. Japan is a very peculiar market. We must not forget that Japan has the society there has a very unique way of looking at housing. There is a great churn of housing happening. So people turn over houses very rapidly within a few decades, and every time they redo it. So what that does is that creates a huge demand and a market. The second thing to understand in Japan is prefab there is not a product where people look at it as a cheap alternative. It's a premium product. However, people want that good quality housing there. So housing is really driving there. People want to pay because they are looking at the high quality outcome for their houses, which is not happening in all markets, and certainly not in Australia, where the cost really becomes paramount for the clients. There is a market culture as well as the industry culture that both is creating that barrier.
Okay, so a question from Mike Corcoran, primarily on retrofit. So Mike says we don't have until 2050 to achieve deep renovation. The critical period is the next 10 years. And to what extent does prefabrication methods lend themselves to that shallow retrofit path where we have to do things quite quickly?
Well, shallow retrofit, I don't know, because I have a different definition in mind. So shallow as opposed to deep is more kind of the amount of savings.
It's the renovation path, so it's actually just meaning we have to do it quickly.
We have to do it quickly. Yeah, I'm afraid I don't have all the answers, but like there are a lot of initiatives looking to accelerate that, and it's actually the way to do it, because if you look at traditional methods, we simply don't have the capacity right now. So even more so, because we have to do it fast, we have to turn to prefabrication. And so for me, it's not so much a technical question, because as we see technically it can be done. It's more kind of setting up the conditions to make this possible, which means arranging the amount of demand to make it meaningful for the industry to make the shift, because it's really a shift. And one parameter that I didn't mention before, and I think it's very important, is the tradition and perception in the users, but also in the industry itself. So they need to make the shift. If the conditions are right, they can do it. But
can I ask a specific question that sort of follows on from your presentation? Because obviously you said that the original plan for the renovation that you showed us at the end was to use prefabrication, that then because you were only doing a small number of units, it was easier and more cost effective to do on-site construction. What did you look at what sort of scale you would need to make the prefabrication viable?
That was this information. That's something that came from an industry partner, so the Big Bow, the general contractor. So he has quoted a number, kind of in like maybe 500 to 1,000 in in a
so
because
very significant volume.
But yes, so like for the 12, it definitely did not make sense, also financially. But even for the 200 that we had afterwards, if they had the project with the 200 and a kind of a promise that few of those will come in the coming year, they could consider, but that the conditions were simply not there.
Yeah. Okay. Thank you. I'm just going to see if we can get some other questions here. There are lots of people asking if the presentations will be made available, and the answer to that is yes. We will broadcast that on the website. There's a question for Deo and Malay as to whether these prefabrication modular building projects have opportunities in health and hospitality.
Yes, I'm pretty sure they are, and whereas most of the focus has been on residential in Australia, and that's sort of we have a huge, vast country with different climates and a lot of mining districts in the middle of Australia. So these, what we call pods, have become the fly-in, fly-out accommodation, if you like, and they are in the mindset very temporary. So as a result, it explains some of the slow uptake of these in Australia. But in the schools area, yes, they have been around for a long time, not very, very popular. And in the health area, they act as temporary places when it comes to smaller size buildings. But in the larger cases, of course, the opportunity now is there. The UNSW new building design that I showed, projects of that scale can actually be looked at from this perspective much more efficiently.
Okay, thank you, Deo. We've got a few more questions I think we can fit in with a few minutes to go. There's a question here from Nicholas Banton, who wants to know what sort of insulation materials are being used in these projects, and also what's holding back the use of robotics. I saw various types of insulation in your presentation, Malay, and also Thaleia.
Okay, I'll just quickly go. In the project that we worked on, the insulation was primarily either glass wool or polyester bats. There is increasing use of polystyrene, so expanded polystyrene or extruded polystyrene. Many other companies are using the spray polyurethane, but there are major issues with environmental and human toxicity issues, so that we discourage. But I'm sure there is more to that Thaleia can talk about.
Yeah. Yeah, so like for example, in the project we applied, I think they were both expanded polystyrene, even though that was not kind of our ideal choice. Again, follow the financial consequences. In timber frame construction, mineral wool is also very, very common. The spray polyurethane I don't see very often. Overall, I mean, I would say at this point is either some polystyrene expanded or extruded, and or a mineral or a glass wool, for which especially in depends what you do, but I would say these are the more popular, but I think that's standard. And the thickness, which also could be important for zero energy renovation, you would go I would say at least 15 centimeters.
Yeah, okay. And robotics, do they have a role?
Yeah, that's a good question. To some extent, like to current prefabricated practices, to some extent, we are starting now a project where we're going to look about how can we change the processes in industrialized construction for refurbishment to incorporate that. It's not to a large extent, and I would say again, it's a cost question. Like if you cannot even set a production line, let alone have a robot to do that.
Okay.
And plus robotically, as far as I know, without being the expert, the speed is not something that could accommodate. It's not yet something that could accommodate the type of production we need. The speed of working with robots.
Fine, thank you very much. We've just got a few minutes left. I'm just going to see if there's a quick question that we can respond to. So there's a question here. So yeah, the high investment costs call for a lack of benchmark over a whole life cycle. Sorry, can't really interpret that question at the moment. Yes, okay, here's one. So to keep investment costs low, to what extent do you think mixed approaches are valuable where there's a certain amount of on-site construction and a certain amount of prefabrication.
So that's in Australia, that's been very common. So some of the mass housing groups, they fabricate some of the framing and structures and assemble on site while they do a whole lot of stuff on site. And that's where the middle ground has been in Australia in many types of construction, residential and non-residential as well.
Okay, I think I'm going to call a halt there and just sum up a little bit across the presentations and thank everybody. So first and foremost, thank you to our speakers for presenting some very interesting topics, and thank you to the audience, obviously, for listening and for asking some interesting questions. I think the whole topic area of off-site construction, both in the context of new build and retrofit, is one that I think we will see evolving and developing rapidly. We obviously see countries where there are deployment of mass construction systems. And I think in retrofit, one of the areas that we're increasingly looking at is the opportunities for mass customization, so that we have standard products that can easily be adapted to lots of different situations. And I think that lends itself to the sort of response to the last question, which is, you know, a mixture of on-site and off-site construction that makes best use of materials and resources and delivers hopefully good value for money over the life cycle of the building. I'm going to begin to draw the session to a close now. So thank you again to the speakers. Thank you to our organisers who've been in the background, making sure that the slides worked properly and that the questions were handled. Thank you to my colleagues, Doreen and our principal investigator, Jackie Glass, who's been helping in the background. And just once again to the audience, thank you for attending. The presentation will be made available on the website, as I said, so just check back with the Transforming Construction Network Plus website in a little while and it will be there for you. Okay, I think we'll draw things to a close. Thank you for your attention, everybody. Goodbye.
Thank you.
Thank you. Bye-bye.